This video is about using integration to find areas between curves. So if you look at our diagrams, we have two functions, f of x and g of x. If we integrate f of x between b and a, we find this area under the upper curve, which is f of x. So I would get all of this, which is underneath f of x. But I also get this bit, because this bit is above the x-axis and underneath f of x. Now, if I integrate between g of x between b and a, then I end up getting this part. So everything underneath g of x between a and b. Then if I do area under the upper curve take away area under the lower curve, what I get is the area in between. So that is obviously what remains, which is there. So that means all that disappears and all I'm left with is the area in between the two curves. Similarly, if we have this one, f of x, if I work out the area under f of x, then I'm getting this part, which is under f of x, but I'm also getting this part. If I subtract the area under g of x, then that means I need to take off all this bit. So I'm left with the area underneath the curve. So if you want to work out the area in between curves, it's easier to do f of x take away g of x and integrate between b and a. So it's easier to do this instead of doing the two separate integrals and then subtracting it. Okay. Now this rule only works as long as the curves do not intersect. So as long as the curves do not intersect between a and b. So they can meet at a and b, but not in between it. Okay, so let's look at this. So does the rule work when, so obviously in these two cases, the curves were above the x-axis. So does it work when one of the curves go below? So let's look at this case. So if it so happens that it is actually true, so if we're trying to find out area under curve, if we want to try and find out the area in between, so which is this, between the two curves, then you can see the area between the two curves. Area between the two curves is equal to b plus d. Now let's look at the area under curve f of x. Now the area under curve f of x is a plus b plus c. That's a plus b plus c. Okay, area under curve g of x, so under curve g of x is a, but then we've got the d part which is below the x-axis, so we need to take away d, and then plus c. So if I highlight it, so for the first one, area under curve f of x is a plus b plus c, because it's all of this. That's the first one, so this is this one. Okay, if I change it to area under curve g of x, then under g of x is obviously, oops, undo, is going to be this part, which is a, this part, which is c, and the d, but because it's below the x-axis, I need to subtract d. So if I'm doing f of x minus g of x, all I'm doing is a plus b plus c, take away a minus d plus c. So the a's cancel out, the c's cancel out. All I'm left with is b, take away negative d, which is b plus d, which is the same thing as this. So it does work out. So the rule applies even when the curve goes one or both of the curves go below the x-axis. Again, it doesn't apply obviously when there are intercepts in the middle. So if you have a situation like this, note, it does not work when there are intercepts between a and b. So where the two functions between a and b. So if I had something like this where we're integrating between a and b, but in between those two points a and b, your curve and your line are intersecting. So if they intersect, then straight away you can't use this formula. So now let's apply this rule to some examples. Let's go through these. So diagram shows a curve with equation y is equal to 5 plus 2x minus x squared and the line with equation y is equal to 2. The curve and the line intersect at the points A and B. Find the x coordinates of A and B. Okay, so first thing I need to do is, because it's the curve and the point the line are intersecting at point A and B, I need to solve it simultaneously, which means I've got y is equal to 2 and y is equal to 5 plus 2x minus x squared. So because they both have y as a subject of the formula, I can just equate the two things. So 2 is equal to 5 plus 2x minus x squared. Let's move everything to the left hand side. So I get x squared, take away 2x, positive 2 take away 5 gives me negative 3 is equal to 0. That means x is equal to, if I factorize it, I get x minus 3 times x plus 1 is equal to 0, which means x is equal to 3 or x is equal to negative 1. Now a is in obviously a smaller value of x, so a must be equal to negative 1. So a must be equal to negative 1, and because is on the line y is equal to 2, it must be y is equal to 2. And for b, it must be the higher x value, which is 3. And again, the y value at that point is 2 because it is on the line y is equal to 2. Okay, b. So the x coordinate of a is equal to minus 1 and the x coordinate of b is equal to 3. Okay, the shaded region R is bounded by the curve and the line. Find the area of R. Okay, now if you can clearly see it's the area of the curve, take away the area under the line. So it's the same thing as integrating between the 2 points, which is 3 and minus 1. So 3 and minus 1. So it's the area under the curve. So it's going to be 5 plus 2x minus x squared. Take away the area under the line, which is equal to 2. Y is equal to 2, so just 2. All integrated with respect to x. When we simplify this, 5 take away 2 gives us 3, so it's just going to be 3 plus 2x minus x squared integrated with respect to x. So when we integrate this, we get 3x plus 2x squared over 2, which gives me just x squared. And minus x squared integrates to minus a third x cubed. Between 3 and minus 1. Don't forget it's a minus 1. Okay, all I need to do now is substitute 3 first in and then substitute 1 into the expression. So I get 3 times 3 plus 3 squared minus a third times 3 cubed. Take away 3 times negative 1 plus negative 1 squared minus a third times negative 1 cubed. Now if I have done this right in my calculator, first bracket gives me 9. So 9 from the first bracket. The second bracket gives me a negative number, which is negative 5 over 3. 9 take away negative 5 over 3 gives me 10 and 2/3. Okay, next question. The diagram shows a sketch of a part of the curve with equation y is equal to x squared plus 1 and the line with equation y is equal to 7 minus x. The finite region R1 is bounded by the line and the curve. The finite region R2 is below the curve and the line and is bounded by the positive x and y axes as shown in the diagram. First thing is find the area of R1. So first thing I need to do is find these intercepts, which means I need to solve simultaneously with the two equations. So A is y is equal to x squared plus 1 and y is equal to 7 minus x. Because both of them have y as the subject of the formula, I can equate the right hand side. So I get x squared plus 1 is equal to 7 minus x. If I rearrange to get everything to the left hand side, I get x squared plus x plus 1 take away 7 gives me negative 6. If I factorize this, I get x plus 3 times x minus 2 is equal to 0, which means x is equal to negative 3 and x is equal to 2. So that means here, this is negative 3 and this is 2. So what I'm trying to find R1, what I'm trying to do is integrate first between 2 and negative 3 I need to do the area of the, area under the equation of the line, which is 7 minus x. 7 minus x, take away the area under the curve. So it's going to be take away x squared plus 1. So just remember, it's area under the line, take away the area under the curve. So you have to do it that way, run. And integrate with respect to x. Okay, so if I do that correctly, I'm integrating between 2 and minus 3. I end up getting minus x squared and minus x. 7 take away 1 is positive 6. Okay, now that I've simplified, all I need to do is now integrate. So I get minus a third x cubed minus a half x squared plus 6x with upper limit as 2 and the lower limit as minus 3. Okay, so I need to first substitute in minus a third times 2 cubed minus a half times 2 squared plus 6 times 2. Take away minus a third times minus 3 cubed minus a half times minus 3 squared plus 6 times minus 3. The first bracket gives me 22. So 22 over 3. Take away the second bracket gives me negative 27 over 2. And when I simplify this, I get 125 over 6. So that's part A done. Okay, part B now. So find the area of R2. So to find the area of R2, what I need to do is split it up into two parts. So a triangle and the area under the curve. Now what I do know is this is, the base of this triangle is 5. So I've got a triangle with the base as 5. Now I need to know the height. So I need to, the y value for, so when x equals 2, y is equal to 7 minus x, which is 7 minus 2, which is equal to 5. So this means that the height is also 5. So the area of the triangle is equal to half times 5 times 5, which is 12 and a half. Okay, now I need to next work out the integral. So I've worked out the triangle, which is there. Oops, undo. The triangular part is done. Now I need to work out the area under the curve. So this part, I'm just going to highlight it. This part I need to work out. So that is, that part I get by integrating between 2 and 0, the area under the curve. So it's going to be x squared plus 1 dx, which is when I integrate it, I get a third x cubed plus x between 2 and 0, which means I need to substitute first 2 in, and then when I substitute 0 in, I know I get 0. So I get 8 over 3 plus 2, which is equal to 14 over 3. So R1 will be the same thing as 14 over 3 plus 12 and a half, which is equal to 103 over 6. Sorry, this was R2, not R1. And that one was therefore R1 is equal to 125 over 6. Okay. Let's go to the next question. So it says the diagram shows the line y is equal to x minus 1 meeting the curve with the equation y is equal to x minus 1 times x minus 5 at A and C. The curve meets the x-axis at A and B. A is write down the coordinates of A and B and find the coordinate of C. So A and B are quite easy. All you need to know is the roots. Roots for y equals x minus 1 times x minus 5 are x is equal to 1 and x is equal to 5. Therefore, A must be 1, so that's 1, 0, and B must be 5, 0. Therefore, A is equal to 1, 0, because B is bigger, so B is equal to 5, 0. Now to find C, because it's the point where the line and the curve intersect, we need to solve it simultaneously. So y is equal to x minus 1 and y is equal to x minus 1 times x minus 5. If we put these two together, we get x minus 1 is equal to x minus 1 times x minus 5. If we expand the bracket on the left-hand side, right-hand side, we get x squared minus 6x plus 5. If we take everything to the right-hand side, I get x squared minus 7x. Positive 5 take plus 1 gives me plus 6 equals 0. If I factorize it, I get x minus 6 times x minus 1 is equal to 0, which means x is equal to 6 or x is equal to 1. Now clearly 1 is here, so that 1 must be 6. So c must be 6, so it must be x. So at c, x is equal to 6 and y would be equal to, you can use either one to substitute into to get your y value. So y must be equal to x minus 1, which means it's 6 minus 1, which is equal to 5. So c is equal to 6, 5. Okay. B. It says find the area of the shaded region bounded by the line, the curve, and the x-axis. So what you can do for this one is, if I draw a triangle here, so this one was 6, 5. Then if I do the area of the triangle and then subtract the area under the curve between B and C, then that would give me what I want, yeah? So first thing I need to do is area of the triangle. So this triangle, so part B, for this triangle, it goes from 1, 0 to this part, which is 6, 0. So that means that base of this is 5. And the height, because C is 6, 5, the height is also 5. So area of triangle is equal to 5 times 5 divided by 2, which is also 12.5, or you can write it as 12.5. Okay, next we need to do work out the integral. So next, this is the part that we need to work out now, which is integrating the curve between 6 and 5, so x coordinates of 6 and 5. So between 6 and 5, you're integrating the curve, so it's going to be x minus 1 times x minus 5 dx. When you expand the bracket, that's the same thing as integrating x squared minus 6x plus 5 dx. When you integrate this, you get a third x cubed minus 6 over 2x squared, which is minus 3x squared, plus 5x, upper limit of 6, lower limit of 5. Okay, so when you substitute this in, you get a third times 6 cubed minus 3 times 6 squared plus 5 times 6. Five times 6. Take away a third times 5 cubed minus 3 times 5 squared plus 5 times 5. Okay, for the first one you get negative 6. And for the second one you get negative 25 over 3. And when you input this into the calculator, you get 7 over 3. Okay, so if I want to write the area of shaded region is equal to area of triangle, take away the part under the curve that I just worked out, which is equal to 12.5, take away 7 over 3, which is equal to 61 over 6. The next question. So the diagram shows part of the curve C with equation y is equal to x cubed minus 9x squared plus px, where p is a constant. The line L has equation y is equal to y plus 2x is equal to q, where q is a constant. So we have two unknowns, p and q. The point A is the intersection of C and L, and C has a minimum point at B. The x coordinates of A and B are 1 and 4 respectively. So A is 1 something, B is 4 something. Show that P is equal to 24 and calculate the value of Q. Okay, so what we do know is B is a minimum point. So at a minimum point we know at B we know dy dx is equal to 0, which implies that when we work out dy dx must be equal to 3x squared minus 18x plus p. Okay, dy dx is when x equals 4, so when x equals 4, because b has x coordinate 4. When x is equal to 4, we know dy dx is equal to 0, which implies 0 is equal to 3 times 4 squared minus 18 times 4 plus p, which means 0 is equal to 48 take away 72 plus p, which means minus 24 plus p is equal to 0, which means p is equal to 24, which is what we wanted to show. To find point A, we need to solve simultaneously. So we have y is equal to q minus 2x, if we rearrange to make y the subject, and we've got y is equal to x cubed minus 9x squared plus px. When we put them together, we've got q minus 2x is equal to x cubed minus 9x squared plus px, but p is 24, so we can replace it with 24x. Now we know that when we solve it simultaneously, x equals 1 is the solution. So substitute when x equals 1, we've got q minus 2 times 1, which is 2, is equal to 1 cubed, which is 1, minus 9 times 1 squared, which is minus 9, plus 24 times 1, which is 24. So q minus 2 is equal to 1 plus 24, 25 minus, oh, sorry, I thought that was a q. 25 minus 9, which is 16, which means q is equal to 18. Okay, so we found the value of q. B, the shaded region R is bounded by C, L, and the x-axis. Use calculus showing all the steps in your working and using the values of P and Q. Find in part A, and using the values of P and Q found in part A, find the area of R. Okay, so let's label this. So this is y is equal to x cubed minus 9x squared plus 24x. This equation of this one is, the line is y plus 2x is equal to q, which is 18, which means y is equal to minus 2x plus 18. So if I want to find this point, and the line L intersects x-axis at 0 is equal to minus 2x plus 18, because when it intersects the x-axis, y is equal to 0, which means 2x is equal to 18, which means x is equal to 9. So we know at this point x is equal to 9. Okay, so if I work out, first split this R into 2, which is a right angle triangle and the area, and this area under the curve, then, so let me just write B here. So first thing I need to do is work out the area of the triangle, so that means I've got, this point is, so A was 1. The x value of A is 1. If I substitute 1 into the equation of the line, I get minus 2 times 1 plus 18, which is minus 2 plus 18, which is 16. Okay, which means from the height of this right angle triangle is 16. Okay, and the base, because it starts from 1, A, which is 1, the x value of A is 1, then 1 to 9 is 8. Okay, so the area of the triangle is equal to half times 16 times 8, which is equal to 64. Now I need to work out this area, okay, which is the area under the curve between 0 and 1. Okay, so area under the curve, 1, 0 of x cubed minus 9x squared plus 24x dx, which when we integrate it, we get a quarter x to the power 4 minus 9 over 3, which gives me 3x cubed plus 24 over 2, which is 12x squared between 1 and 0. So all I need to do is substitute y in first. And when we substitute 0 in, we're just going to get 0. If we input this into our calculator, we just get 9 and a quarter. So the area of R is area of triangle plus the orange part that we just worked out, which is here. This is the orange part. So it's going to be equal to 64 plus 9 and a quarter, which is equal to 73 and a quarter. The next question. The diagram shows a sketch of the curve with equation y is equal to 2x minus x squared and the line ON, which is normal to the curve at the origin. Find an equation of O to n. Because this is normal, I know I need to differentiate this. So if I differentiate dy, so if I dy dx, I get 2 minus 2x. So I need to find the gradient at the origin. So dy dx at x equals 0 is 2 minus 2 times 0, which is just 2. This is the gradient of the tangent. The gradient of the normal is the negative reciprocal of the gradient of the tangent, which is equal to minus a half. Okay, now we know using y minus y1 is equal to m times x minus x1. I know that, I know my gradient for my tan normal is minus a half. M is equal to minus a half. And x1, y1, a point that it goes through is 0, 0. So that means I get y minus 0 is equal to minus a half times x minus 0, which means y is equal to minus a half x. So that means y is equal to negative half x. So that was part A done. Part B now. Show that the x-coordinate of the point N is 2.5 and determine its y-coordinate. So again, because N is where the curve and the line intersects, I just need to solve this simultaneously. So I've got y is equal to 2x minus x squared and y is equal to minus a half x. If I equate the two, because y is the subject of both formulas, I've got 2x minus x squared is equal to minus a half x. Okay, if I collect everything to the right hand side, I get x squared minus 2.5 x is equal to 0. If I factorize it, I get x minus 2.5, x times x minus 2.5, which means x is equal to 0 or x is equal to 2.5. Let's just write it as 5 over 2. Because x equals 0 is this one, n must be 5 over 2, so it must be x is equal to 5 over 2. So y must be, since x is equal to 5 over 2, we can substitute into either. Y must be equal to minus a half times 5 over 2, which is equal to minus 5 over 4. So that means n must be equal to 2.5 and minus 1.25. So that was the answer for A. This is the answer for B. You see, the shaded region shown is bounded by the curve and the line O to N. Without using a calculator, I determine the area of the shaded region. So this is C. Because it's the area of the curve, take away the area of area under the line. It means we need to just integrate between O to N, which is 2.5, between 2.5 and 0. So remember, this is 2.5 and that point is 0. So it's area of the area under the curve, so 2x minus x squared, take away the area under the line, so dx, which is the same thing as 2.5 to 0, 2x minus a half x is 2.5x, so 5 over 2x minus x squared. Oops, undo. We still haven't integrated, so I need to write dx. So 5 over 2 divided by 2 becomes 5 over 4 x to the x squared minus a third x cubed, substituting in 2.5 and 0. When I do this, I get 5 over 4 times 2.5 squared minus a third times 2.5 cube. When I substitute 0 in, I get 0. If I put this into the calculator, I end up getting 125 over 48. A and B are 2 points which lie on the curve C with equation y is equal to minus x squared plus 5x plus 6. The diagram shows C and the line L passing through A and B. Calculate the gradient of C at the point where x is equal to 2. Now, because it's a gradient question, I know I need to do dy dx. So when I calculate dy dx, I end up getting minus 2x plus 5. So because we're trying to find dy dx when x is equal to 2, so I just need to substitute it into the equation for the gradient function, which is minus 2 times 2 plus 5, which is equal to negative 4 plus 1, plus 5, which is 1. B. The line L passes through the point with the coordinate 2, 3 and is parallel to the tangent to C at the point where x is equal to 2. Find an equation for L. So I know the gradient at x equals 2 is 1. So using m is equal to 1, because the gradient is equal to 1 at x equals 2. And we know that the coordinate that it goes through is 2, 3. x1, y1 is 2, 3. And y minus y1 is equal to m times x minus x1. What we end up getting is y minus 3 is equal to 1 times x minus 2, which means y minus 3 is equal to x minus 2, which means y is equal to x plus 1. So this is the equation, y is equal to x plus 1. This one is y is equal to negative x squared plus 5x plus 6. Okay, C is find the coordinates of A and B. So because it's the point where the curve and the line intersect, we need to solve it simultaneously. So you've got y is equal to negative x squared plus 5x plus 6, and y is equal to x plus 1. So we need to equate them because y is the subject of the formula. So negative x squared plus 5x plus 6 is equal to x plus 1. If we take everything to the right hand side, I get x squared, x take away 5x is negative 4x, 1 take away 6 is minus 5. So when I factorize it, I get x minus 5 times x plus 1 is equal to 0, which means x is equal to 5 and x is equal to negative 1. Now I need to substitute into the equation for the line, so y is equal to x plus 1. So using y is equal to x plus 1, then when x equals 5, y must be 5 plus 1, which is 6. And when x is equal to negative 1 plus 1 is 0, so y is equal to 0. That means a must be minus 1, 0, because it's here. It's on the x-axis. So A must be equal to minus 1, 0, and B must be equal to 5, 6. The point D is the foot of the perpendicular from B on the x-axis. So D, find the area of the region bounded by C. So region bounded by C, the x-axis. So C is this, which is this, the x-axis, the y-axis, and BD. Okay, so what we're trying to find is this part and this part together. Okay, so if I'm trying to find that, it's just the area under the curve. So this is D. So the area under the curve between B was 5, 6. So x value of, so B is 5, 6, and this is 0, 0. So it's between 5 and 0. So integrating between 5 and 0, the area under the curve. So it's going to be minus x squared plus 5x plus 6 dx, which when we integrate it, we get minus a third x cubed plus 5 over 2x squared plus 6 between 5 and 0, which is the same thing as substituting minus a third times 5 cubed plus 5 over 2 times 5 squared plus 6 times 5. When I substitute 0 in to the expression, I get 0. If I put this into the calculator, I get 305 over 6. You find the area of the shaded region. So what I need to do is, because I know the answer from part D, all I need to do is take away the area of the trapezium. So when I think of the trapezium, I've got 0, 0 here. The point B is 5, 6. Do we know what this point is here? This point is when x is equal to 0. So, sorry, x is equal to 0 at that point. Sorry, here. We want this point. This is where the mistake happened. Oops. Undo. So we don't want this point. We want this point. So when you substitute 0 in there, we get 1. Yep, so that must be 0, 1. Okay, and D, because it's directly underneath B, it must be 5, 0. Okay, so the area of the trapezium, the two parallel sides are this. So area of trapezium is equal to half times A plus B times H, which is equal to A in this case is equal to 1, B is equal to 6, H is equal to 5. So that means half of 1 plus 6 times 5, which is equal to 7 times 5 divided by 2, which is 17.5. Okay, so let me just write this a bit neater here. So H is equal to 5. So that means shaded area is equal to answer from part D, which is 305 over 6 minus 17.5, which is a trapezium, which gives us a value in our calculator of 100 over 3. Okay, last question that I'm going to go through. So the diagram shows part of the curve with equation y is equal to p plus 10x minus x squared, where p is a constant, and part of the line L with equation y is equal to qx plus 25, where q is a constant. Again, two unknowns. The line L cuts the curve at the points A and B. The x-coordinate of A is 4, so 4 something, and the x-coordinate of B is 8. The line through A parallel to the x-axis intersects the curve again at the point C. Show that P is equal to minus 7 and calculate the value of Q. So because we're trying to find two unknowns, and we know 2 points where the curve intersects, so we need to solve it simultaneously first. So we have y plus qx, y is equal to qx plus 25, and y is equal to p plus 10x minus x squared. When you combine these two, you get p plus 10x minus x squared is equal to qx plus 25. Plus 25, not just plus 5, plus 25. So when x equals, so we do know 2 points that it goes through. So when x equals 4, we know p plus 10 times 4 minus 4 squared must be equal to q times 4 plus 25, which means I get p 40 take away 16, which is p plus 24, must be equal to 4q plus 25, which means if I take all the unknowns to one side, I get p take away 4q, and 25 take away 24 is 1. So that would be equation 1. Solving A. Okay, if I do the same thing when x is, because it intercepts at b as well, when x equals 8, then we get p plus 10 times 8 take away 8 squared is equal to q times 8 plus 25, which means p 80 take away 64 is p plus 16 is equal to 8q plus 25. If I take the unknowns all to the left hand side, I get p minus 8q is equal to 25 take away 16, which is 9. So in equation 2 here. So if I do 1 take away 2 to eliminate p, then I get p take away p, which gets lost, which eliminates. Minus 4q take away minus 8q gives me 4q. 1 take away 9 gives me minus 8, which means q is equal to minus 8 divided by 4, which is minus 2. Now, if q is equal to minus 2, since p minus 4q is equal to 1, p minus 4 times minus 2 must be equal to 1, which means p plus 8 is equal to 1, which means p must be equal to 1 take away 8, which is minus 7, which is what we wanted. Okay, part B. Calculate the coordinate of C. Okay, so since A is on the line, so you just rewrite these equations again. So it's going to be y is equal to minus 7 plus 10x minus x squared, and y is equal to minus 2q plus, 2x minus 2x plus 25. Now, since A lies on the line, we know when x equals 4, y must be equal to negative 2 times 4 plus 25, since it lies in the line, which is equal to y is equal to negative 8 plus 25, which means y is equal to 17. So that line is y is equal to 17. So to find C, we're trying to find y is equal to 17 is this line, and the curve where they intersect. So we have to solve it simultaneously. Y is equal to 17 is a straight line from A to C, and the curve has equation y is equal to minus 7 plus 10x minus x squared. If we solve it simultaneously, I get minus 7 plus 10x minus x squared is equal to 17. Take everything to the right hand side, I get x squared, take away 10x plus 24 is equal to 0. If we factorize it, I get x minus 6 in one bracket, x minus 4, which means x is equal to 6 or x is equal to 4. Now, we know it can't be 4 because that's A, so it must be x is equal to 6. So C is equal to 6, and because it goes through, is on the line y is equal to 17, it must have y value 17. Okay, the shaded region in the diagram is bounded by the curve and the line segment AC. Using algebraic integration showing all your working, calculate the area of the shaded region. So what I need to do is the area under the curve, take away the area of the line A to C. So it's the same thing. So if I just undo it, so what we're going to be doing is we're going to work out the area under the curve from A to C, and then take away the area under the line y is equal to 17. So it's the same thing as, because you're integrating between A and C, so this is C. So because A is 4, so 4, and C is 6, so integrating between 6 and 4. So it's the area of the curve, so minus, under the curve, minus 7 plus 10x minus x squared. Take away the area under y equal to 17, so take away 17 dx. So if we simplify this, this is the same thing as integrating between 6 and 4. Minus 7 take away 17 gives you minus 24 plus 10x minus x squared dx. Now we can integrate. So when we integrate, we get minus 24x plus 10 over 2 gives me 5x squared minus a third x cubed between 6 and 4. So first thing I need to do is substitute 6 in. And then I need to substitute 4 in. So the first bracket will give me negative 36. And the second bracket gives me negative 112 over 3. Now when I put this into my calculator, I end up getting 4 over 3. And that's the final answer.